Good evening, everyone. Hopefully, you have had a fantastic Friday. I know Friday came and the week has been long, but we finally made it. And now we are here enjoying life and enjoying ourselves today. So, we are going to learn about the rules or laws of arithmetic and exponents. And the reason why I'm bringing this up is because this particular rule transcends from kindergarten all the way until high school, and even if you go off to college. This allows you to see how these rules work. So, just going to go over a few laws. If you have any questions, of course, you can comment them below because you know Miss Chris loves to help you guys. So, if you can hear me, please give me a thumbs up, a heart, anything to let me know that you can hear me so we can get started. Thank you. Let's get started, everyone. All right, beautiful people. We are going to go through each law that is listed above. And on the last one, I'm going to take my time by going step by step when it comes to exponent laws. Those laws of exponent, those laws are very tricky. So I'm going to give examples of every law that we do today, but specifically the exponent one, because this one is key for algebra, pre-algebra, and pre-calculus. Okay? So, first things first, we are going to deal with commutative versus associative. So, what is the difference between commutative and associative? Commutative is a property that states, well, if A plus B equals C, then B plus A also equals C, meaning A plus B is the same as B plus A. So commutative property is basically saying when you are adding, also when you are multiplying, that they will give you the exact same answer because they are the same. So, best example that I can give you when it comes to commutative property. You have 3 times 2, that equals 6. You also have 2 times 3. That also equals 6. So whether you write 3 times 2 or 2 times 3, both of those give you 6. Another example. Four plus 5 gives me 9. But also 5 plus 4 gives me 9. Therefore, whether I write 4 plus 5 or 5 plus 9, both numbers will still give me the answer of 9, meaning no matter how you write it for adding or multiplying, the numbers will be exactly the same. Now, mind you, the first two laws of commutative and associative, distributive, which is a multiplication, identity, and inverse. All of these laws deal with addition and multiplication. Distributive law, that's only to multiplication, but commutative, associative, identity, and inverse all are adding and multiplying properties. Do you guys have any questions about commutative? It's 9. Both. All right, moving on to associative. Associative simply is you are moving a set of parentheses from one side of a number to another side of a number. Meaning, if you have A plus B plus C, whether the parentheses are here or here, your answer will still be the same. Now, the difference between commutative and associative is that the adding or multiplying of these numbers is basically based off of PEMDAS as well as GEMS, what we learned on Wednesday. So with associative property, basically all you're going through is learning the operation portion of adding these numbers. Also, A plus B you would add A plus B together and then add it to C, or you could add B plus C together and then add it to A. But either way, the parentheses are shifted. Once those numbers are shifted from either the first two numbers or the last two numbers, your answer will still become the exact same number. And the same thing goes if you're multiplying. So say for instance, I have parentheses 1 plus 2, close parentheses, plus 3. Well, based on the operation property, you would do the operation in the parentheses first, which would be 1 plus 2, which is 3, plus 3, and that gives me 6, right? Well, based on the associative property, if I do 1 plus parenthesis 2 plus 3, well, I would bring down my 1 and my plus and say 2 plus 3 is 5, and 1 plus 5 gives me 6. So all associative property is the interchanging or the sliding of the parentheses on either you're adding the first two numbers together and then, because basically associative property is a grouping law where either you're adding the first two numbers together and then adding the last number, or you're adding the last two numbers together and then adding the first number. So either way, know that the associative property is based off of grouping, adding, and multiplying, meaning either you are going to add within the first two numbers that are in the parentheses or the last two numbers that are located in the parentheses. And whatever answer you get, you add the additional number. Either whatever number you get, whether you have a parentheses on the front or back, it will give you the exact same answer. And the reason why I did the juxtaposition of commutative and associative, because those two are the main ones that always get confused. Most people think commutative would be the one with the parentheses, vice versa. The associative is the one with the reversing of the numbers. Just always remember that commutative, you add front or back with no parentheses, and associative you add front to back with parentheses. So commutative, no parentheses, associative with parentheses. Both laws mean whether you add it front or back, you should get the exact same answer, adding or multiplying. Any questions? All right. Moving on to the distributive property. Distributive property says if A is multiplied to B plus C, then A is multiplied to B plus A being multiplied to C, meaning you're literally taking the A and distributing it throughout the parentheses, right? So, say for instance, I have 2, and that is 3 plus 7. Let's try that. So that means in distributive law and property, 2 would be multiplied to the 3, and 2 would be multiplied to the 7. Then 2 times 3 gives me 6, plus 2 times 7, which gives me 14. And then that gives me a total number of 20. Now, with distributive property, this come in handy for when you start doing algebra. Reason being, algebra has things like x, y, a, c, and 7x squared. With distributive property, it shows you how to multiply the outer number to everything within the parentheses. So, say for instance, erase this right quick. For those who are getting ready to take algebra or are going through pre-algebra, algebra 1, algebra 2, pre-calculus, you will see this a lot with distributive property. You'll see something like 2 times x plus 5. Well, based on distributive property, that means I multiply the 2 to the x and I multiply the 2 to the 5. So then 2 times x is 2x. Whenever you are multiplying a letter to a number, it's the letter in the number. I know it seems like it shouldn't be that simple, but it really is that simple. 2 times x will always be 2x. So Once we multiply the letter to the number, then 2 times 5, that gives me 10. So based on the distributive property, I have went from 2 times x plus 5 because you can't add x and 5 together. All you can do is distribute the 2 to the x and the 5, which allows you to get 2x plus 10. Another cool distributive property is when you start doing binomials in algebra. And we'll touch on this a little bit more when we get ready to multiplying monomials, meaning you are multiplying a monomial to a binomial. Monomial means one term, which would be a, to a binomial, which could be 2x plus 5. So now, fix my a because my a looks like a 9. Sorry about that, guys. So if I distribute, that means 2 is going to be multiplied a is going to be multiplied to the 2x plus a being multiplied to the 5, which when we are done will give me a 2ax plus a 5a. When we start on algebra week after next, I will go more in depth with the multiplying of the monomials as well as multiplying with binomials, because you're going to see something called FOIL, which stands for first, outer, inner, last, which is literally a distributive property or formula or process. And so we'll get into that portion with our Algebra 1 and Algebra 2 high school week. You don't have to be a high schooler to learn this information. You can always check out these videos to make sure you are staying ahead, because I'd rather you be ahead than behind. Anyone have any questions so far? All right, class. Moving on to the next law and property, which is the identity law. Identity law is if I'm adding a to 0, if I'm adding a to 0, it equals a. If I'm multiplying a to 1, for those who use dots or x's, it will equal a. So identity law says 1 plus 0 equals 1, and 1 times 1 equals 1. 2 plus 0 equals 2. 2 times 1 equals 2. So as you can see with the identity law, all you are realizing is that whether you're adding or subtracting, identity, of course, means itself. In addition, if you add it to 0, it will still be itself. If you multiply it by 1, it will still be itself. That means your answer from the beginning to end will, what you add to 0 or what you multiply to 1 will be itself. It does not change. So whether it's 2 plus 0, 50 plus 0, 5 times 1, or 501 times 1, all of them will equal the answer that you are multiplying by 1 or adding to the 0. Any questions on the identity law? All right, moving on from the identity law. Now we have the inverse law. Inverse law says, hey, if I add my inverse, it should equal 0. As you can see, you have when we dealt with identity gave you 5 plus 0 equals 5. Now, how did they come up with the inverse law, which basically looks like you're dividing and subtracting when it's the inverse law of addition and the inverse law of multiplication. This is based on how I figured it out. Of course, there's probably another book that came up with why it's the way it is, but this is my concept as to how this came about. So we know that 5 plus 0 equals 5. Question is, how do I turn the 0 into the inverse, and how do I make the 5 on the other side of the equal sign 0? By subtracting on both sides. So I will subtract 5 from here and 5 from here, which gives me 5 plus negative 5 equals 0. Now, this is my philosophy. This is how I came up with the concept, or how I feel like it was identified to go from identity to inverse. But I would recommend doing your research. So, inverse for addition is always 5 plus the inverse of the negative form of that number equals 0. That is the inverse for addition. Now, the inverse for multiplication is if I have 2 and I multiply it to 1/2, it should equal 1. So the inverse states that if I have a whole number and I multiply it to its flipped fraction or flipped inverse, which would be 1/2, that should equal 1. Why? Because when you multiply 2 times 1/2, you first, of course, will put it over 1, because a whole number over 1 makes it the whole number. So 2 times 1, that gives me 2. 1 times 2 still gives me 2. 2/2 is considered a whole, and a whole always equals 1. Same thing if you have a fraction. If you want the inverse, say you have 3/7. Well, the inverse should be 7/3, because 3 times 7 gives me 21. 7 times 3 gives me 21. And of course, if you have the same number on top as you do the bottom, of course, that still makes it a whole, and a whole always equals 1. So, inverse of multiplication, you must always equal 1. And not just equal 1, you must equal positive 1. Because if you remember earlier, we dealt with integers. Integers are whole numbers that are positive and negative. So the inverse of addition deals with positive and negative numbers. The inverse of multiplication deals with positive numbers, and it should always equal positive 1. So if I have a -2, that means my inverse should be -1/2, because -2, if I put it over 1, times -1, that gives me a +2. 1 times 2 gives me 2. And of course, 2/2 still gives me 1. Hey, Anitra, and you're welcome, sweetie. Good seeing you. Do you guys have any questions so far with this? All right, so we have done commutative and associative. We have done distributive law. We have done identity law. We have done inverse law. Now it is the time for the law of exponents. What does that look like? Well, if you give me one moment, I am going to pull up this handy dandy picture that I found that best explains exponent rules. Or the law of exponents. You will need to understand and learn these laws because they come in handy not only for basic math, but definitely in pre-algebra, algebra 1, algebra 2, pre-calculus, and also in calculus. So now, what are the exponent rules? First rule up is the product rule. Product rule says if A is raised to the x power, and a is also raised to the y power, then a exponents can be added to each other. What does that look like in real time? 2 to the second times 2 to the third equals 2 to the 2, erase that right quick, to the 2 plus 3, which gives me 2 to the 5th. So, when you are doing the product rule of the exponent law, know that the basis must be exactly the same for you to add their exponents together. What I mean by is if you have 2 to the second times 3 to the third, really, computer? That's what we're gonna do? Okay. If you have 2 to the second times 3 to the third, you cannot do the product rule. Why? Because they do not have the same base. In order for you to do these rules, you must have the same base for the product, quotient, for the product and the quotient rule. Also, say I do have a to the second times a to the third. Well, that's a to the second plus 3, or a to the 2 plus 3, which gives me a to the 5th. So whether you're doing this by letter or doing this by number, know that the basis must be the same for you to add your exponents together, your powers together. All right, next rule for exponents. Move this just a little bit. And then move it just a tad up that way. Perfect. Now, quotient rule. Just like product is adding, quotient is subtracting. Because, of course, product is multiplication, which means you're going to add, whereas quotient is division, and usually with division, you're subtracting. So, quotient rule says if A is to the X and it's divided by A to the Y, then A is X to the X minus Y. Example of that would be if I have 2 to the 4th and I'm dividing it by 2 to the 1st, then I could subtract my exponents from each other, and that gives me 2 to the 3rd. Now, another way of seeing or doing this, you would also see where, say for instance, you have a to the fourth over a to the third. Another way of fraction is also known as division. So whenever you have a fraction, all you're dealing with is division. So if you have two of the same basis, but they have different exponents on top of each other in fraction form, you are still doing a to the fourth divided by a to the third, which gives me a to the fourth minus 3, and that leaves me with a to the first. Any questions so far? All right. Next up, we have the power rule. And that is when you take a power and raise it to a whole nother power. Well, that is an acceptable rule in math or mathematics as a whole. So, rule is okay, so how do you raise a power to another power? So, based on this rule to the right of me, if a is raised to the x power and that is being raised to the y power, if you're raising a power to a power, all you are doing is multiplying the powers to each other. So, if I have 2 to the 5th and I'm raising it to the 10th power, well, that becomes 2 to the 5 times 10, and that leaves me with 2 to the 50th power. Same process as if you're dealing with letters. A to the 9th raised to the 7th power. That's going to give me a to the 9 times 7, which gives me a to the 63rd power. That's right, Miss Melba. Oh, good seeing you, beautiful people. Okay, where was I? I was just saying hey to everyone that are in the comments. If you are on the Facebook and you're also on the YouTube, thank you again for tuning in. Just going over simple rules that, of course, will help you apply, that are easily applied into multiplication, division, adding and subtracting for the basic operations, as well as moving forward when you start doing pre-algebra, algebra 1, algebra 2, and algebra 3. Yes, ma'am. Just multiply the numbers when doing the product rule. Well, the power rule. Because the product rule, you add them together. But if you're raising a power to a power, you're just multiplying the numbers. All right, beautiful people. Next up, we have, before I move on to this other rule, there's one rule that is missing, which is the identity rule. And I want to go over that because there's also an identity rule in exponents. Identity rule says if I raise a to the first power, it equals a. So if I say 2 to the first, that equals 2. If I say 500 to the first, well, 501 to the first, that will still be 501. And that is the identity rule for exponents. Honestly, I do not know why it is missing because it's one of the most important rules because they have the zero exponent, which means anything raised to the zero power is 1, but anything raised to 1 will always be itself. Case in point, 2 to the second is 2 times 2. 2 to the third is 2 times 2 times 2. So identity rule says, well, hey, if I'm raising it to the 1 power, that means it's just 2 because it's not multiplying to anything. It's just itself. So always remember the identity rule of exponent is if you raise it to the first power, it is itself, whether it's a to the first equivalent a or 500 to the first, which equals 500 or 501. Any questions before we move on to the next exponent rule? All right. We will now be moving on to the power of a fraction rule. If you have a fraction, and it's being raised to a power, the numerator will be raised to that power, and the denominator will be raised to that power. Now this is a game changer compared to what we've been doing. So you have a to the x over b to the x. What would that look like? So say for instance, I have 2 over 3 and I raise it to the third power. Well, that means 2 will be raised to the third and 3 will be raised to the third. power of fraction rule. Whenever you have a fraction and the whole fraction is raised to a power, you raise the numerator and you raise the denominator, both to that rule. So say, for instance, you have 2 to the a raised to the 4th power. Well, 2 will be raised to the 4th and a will be raised to the 4th. Always remember, with the power of the fraction rule, when you have this fraction, you must raise both the numerator and the denominator to that power, because of course it's power of fraction rule. Everything must be raised to a power. Also, if you have two different numbers, A times B raised to a power, the A will be raised to a power and the B will be raised to a power. Now, mind you, someone will probably say, well, hey, why not just go ahead and multiply them together? Well, there's a thing in algebra called variables, and those variables are in letters. And so therefore you can't multiply them into each other, because the only thing you can do with a number and a letter is put them together as a number and a letter. Point of example would be 2x squared. So I'm squaring the 2 and I'm squaring the x. So now that's 2 squared times x squared. Well, 2 squared will give me 4, and x squared is still x squared. This is why you cannot always multiply with the power of the product rule into each other, because it might not always be two numbers. True enough, if you have two numbers such as 2 times 3 and you raise it to the 2nd power, well, 2 times 3, because of the order of operation, you can say 2 times 3, that gives me 6, and 6 to the 2nd power, that gives me 36. But this power rule is really for when you have a variable and a number. What does that look like when you raise both of them to a power? Okay. Any questions about the power of a product or the power of a fraction rule? All right, next up. We have the zero exponent rule. What does that look like? Well, a to the 0 will always equal 1. Now, this is what I learned about the zero exponent rule. And I will read it to you so I can make sure I give the correct wording for it. It says that any number to the zero power is always zero because any number to the zero power is just the product of no numbers at all, which is the multiplicative identity, which what we learned earlier. Of 1. So, whenever you are dealing with a to the zero power, always make sure you say it equals 1. It's part of the rules. I didn't make the rules up, I just follow them. A to the 0 equals 1. So if you have 5, that looks more like a C than a 5. If you have 5,235,123 to the zero power, the answer is 1. So, no matter how big your number is, if it's raised to the zero power, it's forever 1. That rule has not changed, will not change, and will never be changed unless somebody of mathematical geniusness disproves that anything to the zero power is 1. And that also includes letters. So x to the 0 is 1. X 2x to the 0, which will give you 2 times 1. That'll give you 2. But remember that x to the 0, that became 1. Any questions on the zero exponent rule? All right, the negative exponent. Negative exponent says a to the negative x equals 1 over a to the positive x. This rule is for those exponents that are raised to the negative power and you want to make them positive. Because there will be some test you take, and on that test, it will say, hey, all it wants is positive exponents. So what happens if you come up with a negative exponent? Well, say for instance, I have 2 to the negative 1. Based on the negative rule, that means that it's 2, 1 over 2 to the 1, which of course gives me 1/2. A to the negative 5 will give me a to the 5 or a to the 5th. So negative exponent, if it's a whole base with a negative power, you can flip it into 1 over that power, over that base and that power to make it positive. Another way you may see this is, say for instance, you have a to the 4th over a to the 7th. Well, of course, we just learned that the quotient rule, that is a to the 4 minus 7, which is a to the negative 3rd. And if they only want positive exponents or no negative exponents, then that will equal 1 over a to the positive 3rd power. Any questions on the negative exponent? Okay, I have a question. Question is, where did the 5 come from? So say for instance, the 5 came from, either you can do a to the negative 5th, because that was one of the equation that was given, or one of the problems that was given, or say for instance, I had a to the 10 over a to the 15. Well, we know a over a with 2 exponents, that gives me, will have me to subtract them. So then a to the 10 minus 15, that gives me a to the negative 5th. And because it is negative and the paper might ask me to change that into a positive, or doesn't want any negative exponents, to flip it from being a negative exponent, I place it under 1, and you change the negative exponent to a positive one. Did that help? All right. We are now going to move on to our final law and rule, which is fractional exponents. So, how did the fractional exponent come to be the way it is and the way it looks? So, you have a to the 2 times, how did they do this one? Actually, it's not even times. It was raised to a fractional power, which gives me, actually, correction. Let me fix that. A base that is raised to a fractional exponent is then raised to a whole number exponent, which then allows me to say 3 times the 1/2, which gives me 3/2. Because, of course, 3/1 times 1/2 gives me 3/2. So now, the fractional exponent came about when they took a base that is raised to a fraction, take that, and then raise it again to a whole number. And that allows you to get the fractional exponent. Once you get the fractional exponent, the top number tells you what power is raised on the inside, and the bottom number tells you what root is being placed over on the outside. So, with 2 being on the bottom, that means you would do a square root. And with 3 being on top, that means that A is still being raised to the 3rd power. The same thing goes if you have A to the 4/5 power. Me and my handwriting today. I do apologize, everyone. A to the 4/5 power. Bottom number tells me my root. So that means this is the 5th root. And A and the top number tells me the power that this is being raised to. Also, this works for numbers. Say, for instance, you have 2 to the 2/3. Well, the root is a cube root, and the 2 is squared. Numerator goes on the inside, raised to a power. Denominator goes on the outside, and it's the root. Now, a square root doesn't have a 2 because square root is understand that it is the root to the 2nd root power. So when you're dealing with square roots, you will never see a 2. So if you see a root and it doesn't have a number, that is the square root, which is the opposite of squares. So A squared, its opposite is A to the 1/2, which also is known as the square root of A. Any questions on the fractional exponent? Do you need any more examples of the fractional exponent? All right, beautiful people. If you have no questions over the lesson, this part of the live is done. And now we are moving on to our online live tutoring session. So if you have any math questions, such as any math questions for what we learned today, or if you have any math questions in general, you can comment them below and I will put back my handy dandy whiteboard to help you with all of your mathematical needs. Other than that, I hope you are having a fantastic Friday because, hey, it's Friday. It's the end of the week and we are going to enjoy our weekend. So, any math questions you have, no matter how big or small you may think they are, they're very important to me and I am here to help. Other than that, hope you are still having a fantastic Friday. I am Miss Chris and I thank you for tuning into my tutoring session. Good evening. If you are just now tuning in to our tutoring session, we are our live tutoring session. If you have any questions, you can comment them below. If you are on Facebook and you missed the lesson for today, no worries. In the description, there is a YouTube link. Once you click on it or copy it, it'll allow you to open up to the YouTube channel. You will click on the live, and either you can double tap to the left for the rewind, or you can grab the red toolbar and scrub or scroll it backwards so that way you can hear and see what we learned today. Today was an amazing day, had a lot of questions, learned about commutative, associative, identity laws, exponent laws. So if you want to find that information out and you're on Facebook, please click on the YouTube link. It's very useful tools. If you don't want to click on the YouTube link and you're waiting for the live will be over in about 45 minutes. Once the live is over, it will post to my Facebook and my YouTube page for all of your learning purposes. Other than that, my name is Miss Chris. If you have any math questions, all of them are important to me. I am here to help you for today. Other than that, have a fabulous Friday, and I thank you for tuning in. Good evening, and thank you for tuning into this wonderful live tutoring session. My name is Miss Chris of Mathematics for You Tutorial Services. At this time, we are taking questions for the live tutoring session. If you have any math questions, you can comment them below. If you are on Facebook and you missed the lesson for today, the lesson was about the law of arithmetic with commutative and identity and inverse properties, also exponent laws. If you missed that, no problem. The YouTube link that we have is located in the description, and the description may be above or below you. What you can do is click on it, click on the YouTube link. Once you click on that YouTube link, it'll allow you to view the live. And with that live, you can either rewind it with the red bar or you can double tap it to the left, and that'll allow you to rewind what we learned for today. Other than that, if you want to wait until the live is over, no worries to that either. Once the live is over, it'll post to all of my platform of Facebook and YouTube. So all the questions that you have, you can comment them below. Other than that, hope you are having a fantastic Friday. I am here to help, and I thank you for tuning in. Hello, guys. I'm glad that you're still tuning in. I am going to place on the screen my handy dandy calendar of what to expect for next week and for the next month. So, as you can see, next week we are on break. I think I tortured you beautiful people with all this math knowledge long enough. Just kidding. But we're taking a break because, of course, it's 4th of July week. Enjoy yourselves. Enjoy taking a break and enjoying yourselves and having a ball. Now, once the break is over, starting Monday, Tuesday, Monday, Wednesday, Friday, and Saturday, those hours will stay the same. However, Tuesday, I will be doing a crash course online session in case you do need some type of tutoring on Tuesday. That will be from 5 to 6 p.m. I will send out a updated schedule of what time that would look like, as well as what are we learning for the month of July. As you can see, for the first week we are back, we are learning about Algebra 1 and the key components in Algebra 1. Then we are turning around and we're hitting geometry. For those who are wondering why we have shapes in math, geometry explains why. Also, Algebra 1, Algebra 2, pre-calculus with trig. Those are very relatable to each other. You want to tune in for Algebra 1 in order to understand Algebra 2. Tune in for Algebra 1 and 2 to better understand pre-calculus with trig, because all three of those flow into each other. So if you are a rising high school student, also, if you are a elementary student who still wants to continue to learn and just sponge in and soak up all the knowledge of math that your heart of content can offer, guess what? You are welcome to tune in for this tutoring session. You do not have to be an exact high schooler to do the high school portion of our live next month. So all those who want to learn about Algebra 1, geometry, Algebra 2, pre-calculus with trig, please make sure you tune in starting on the 6th, and we will finish out this tutoring live session on August 1st for our summer enrichment program. So if you have any questions, any concerns, of course, as always, you can IM me, you can DM me. You can also text me at 205-542-5062, 205-542-5062. So hopefully you're still having a fantastic and fabulous Friday. We are going to end the live early because guess what? You deserve a break because you worked hard. And since you worked hard, you deserve your break early. So I will see you guys starting on Monday, July 6th, and we will begin in Algebra 1. Other than that, I thank you again for tuning in to this live tutoring session. Of course, if you miss the lesson for today, Facebookers, guess what? The live's getting ready to end. Once it ends, it will post to my Facebook page. It is on my Facebook main page. It is also on my Facebook tutoring page for Mathematics for You Tutorial Services LLC. If you're on YouTube and you want to watch it on YouTube, it's still under Mathematics for You Tutorial Services LLC. And you can click on it. It's called the Laws of Arithmetic and Exponents if you want to review. Other than that, I hope you have a blessed, prosperous, favored, abundant, all your heart and desire content day. Okay? Thank you for tuning in with Miss Chris. I look forward to seeing you and having you again. And of course, this is Mathematics for You Tutorial Service LLC, where we are changing mindsets one problem at a time. Good night.